Alrighty, everybody. So we're on to 6-1, which is radian measure, day 2, which we're going to talk a little bit more about that converting back and forth. So how do we take a degree measure angle and convert it over to a radian and then vice versa? So what we finished up yesterday was getting this conversion. So hopefully everybody's unit circle looks good. So your radian measures match up with your degrees. So take a moment, go ahead and pause the video if you need to. Double check your angles and make sure that your degrees are matching up with your radians. The cool thing about this again is that if you have a reference angle, say 30 degrees, you know any multiple of that is going to have a same reference angle in radians. It's going to be some multiple then of pi over 6. So we talked about some of those benchmarks. So things to remember from yesterday, and then we'll kind of zip into what we're going to do today. Halfway around the circle, pi radians is the same as 180 degrees. That's kind of our benchmark, our conversion factor. So anytime we were thinking halfway around pi, that's 180. So when we did our Smarties lab, we saw those 3 arcs and a little bit more. That's that pi value, so arc length. All the way around the circle then, 2 pi, 360 degrees. So that was our all the way around the circle. All right, so what we're going to do today is kind of take that a little bit further. All right, so what we're going to do then is we're going to change angles that maybe aren't to just regular special unit circle values. So maybe not the 30, 60, 45. Things are a little bit bigger, maybe a little bit harder to deal with. And we're just going to do that conversion. We're going to change from one unit to the other. So if we're going to take a degree measure and change it into radians then in terms of pi, what that's telling me is they want an exact answer, an exact ratio. We will probably do a little bit of calculating on the calculator too, just to think about what the decimal would be. But when they say in terms of pi, they mean an exact ratio. So when you convert to radians, you're multiplying by your conversion factor of pi over 180. So we're going to take our degree measure and multiply by the conversion factor, which is pi radians over 180 degrees. That would give us 720 pi over 180. And all I need you to do is just reduce that fraction. So 180 divides into 720 4 times. So that means it would be 4 pi. That's what they mean by exact answer in terms of pi. Now let's see if this is reasonable. Once around the circle is 2 pi. So 4 pi then would be how many times around the circle? Well, double that, so it'd be twice around the circle. And think about that for the degree measure. Does it make sense that 720 is 2 times around the circle? Well, sure. Once around is 360, twice around is 720. So twice around the circle would be 4 pi. Now, just so we can see what it is, can you guys go ahead and change over 4 pi into a decimal number? So 4 times actually pi, use your pi key, and change that over. What you find when you do that, hopefully, is you get about 12.5, I think it's 7 if you round. Think about this for a second. So when we drew our Smarty picture, we had like 3 arcs or 3 radians to get about halfway around the circle. That means all the way around the circle, we needed how many? Be a little bit over 6, which is the same as 2 pi, right? 2 times 3.14, a little bit over 6. So think about this then. This is twice around the circle, so does it make sense that that would be 12? Well, if once around the circle is 6, that means twice around the circle would be about 12. So that's a reasonable decimal number to be thinking of. So we always want to think if this makes sense, if this number looks good. All right, so let's try another one. So negative 1200. So negatives bother people, but remember negative just means you're going around the circle clockwise. So if it's negative in degrees, it's going to be negative in radian measure as well. We still have the same conversion factor. We still multiply by pi over 180. So we'd have negative 1200 pi over 180, and I just need you to reduce that fraction. So that ends up to be, go ahead and type it in, 1200 divided by 180. That would be negative 20 pi over 3. So when we look at this one, it's still going to be negative in radians. We can get an exact answer. Again, just so we can see what number we're dealing with here, and if it's reasonable, can you change it over to a decimal? So do 20 times pi divided by 3. Should be about 20, because pi is about 3, so that's going to divide out. I think I got negative 20.94. So let's think about that if that's reasonable. So negative 1200, gosh, how many times around the circle would negative 1200 be? So 360 would be 1, 720 would be 2, 1080 would be 3 times around the circle plus a little bit more. So negative 1200 is like 3 full times around the circle and then even a little bit more. So let's see if that makes sense for this number then, for the negative 20.9. Once around the circle in radians is about 6. So twice around the circle would be around 12. 3 times around the circle would be about 8 15 then, and then a little bit more, 20. So it totally makes sense. It's the same location. It should be the same in degrees as it is in radians. Again, when we think about those, trying to name two different names for the same location, think of it that way. All right, let's go the other direction. So now we're going to go from something that's in radians into degrees. So kind of just a clarifying thing here first. Look at the two questions I'm asking you to do. Neither one of them are being specifically identified as something that's actually in radians. So how do you suppose you tell things that are in radians? Well, what don't they have? They're not going to have a degree symbol. So the things that are in degree measure, like our first two, 1 and 2 up there, they had degree symbols after them, so we knew they were in degrees. If there's no marking at all, then you can assume that that's a radian measure. So both of these are in radians to start with. The first one, I think it's a little bit easier to tell. Kind of the dead giveaway there is the pi. But the other one, negative 3.5, a little bit harder to tell. So we're going to take these radian measures and we're going to change to degrees and we're going to round our answers to the nearest tenth. What that tells me is I'm not super worried about exact. They're just saying, yeah, go ahead and multiply in your calculator, see what you come up with. So we're going to multiply by, our conversion factor would be 180 divided by pi. So we're going to multiply by 180 degrees over pi radians. Now for this first one, what happens to the pi values then? Well, they would divide out, leave a factor of 1. So all you're going to have left then is 11 times 180 divided by 3. For mental arithmetic, it might be easier to do 3 divides into 180 60 times and then do 60 times 11, probably a little bit faster, but you can use your calculator if you need to. That would be 660 degrees. So 11 pi over 3 would be equivalent to 660 degrees. All right, let's try the other one. So we have negative 3.5. So thinking about this one, we're still going to do the same thing, except for the pi is not going to divide out because there's no pi in that original radian measure. So when you multiply this one, you're just going to have to times by 180 and actually divide it by your pi key, 3.14, 1, whatever. So use your pi key because that's a little bit more digits. This is going to be approximate. It's not an exact answer, but that's fine. And when we multiply, I got negative 200.5 degrees. Now, I want to talk about reasonableness for this last one. Remember, if it's negative also in radians, it's going to be negative in degrees. I want to think about the picture for this one to see if we can make sense of this a little bit. Let's do a little prediction here. If I graph negative 200.5 degrees, so I would start positive x-axis, negative 180, and then a little bit further, 20.5 further, that would be negative 200.5 degrees. So I'd end up in quadrant 2. All right, now let's talk about what does negative 3.5 mean. I'll do this one in red. So negative 3.5, I'd start in the same location. Halfway around the circle to here is pi. That's negative 3.14. So I need to go negative 3.5. So negative 3.5 is a little bit further, which is going to end up in exactly the same location. It's the same angle measurement. So whatever we see in degrees, we should be seeing the same sort of thing in radians. Now let me talk to you about how you can deal with these on your graphing calculator. So if you can go ahead and grab your calculator for a second. You can do these conversions without having to multiply by the conversion factor. Your calculator will actually do that for you. So let's talk about what that's going to look like. So if you want to change, we'll just do like this last one that we just did. It's a radian measure into degrees. You have to make sure the mode of your calculator, so if everybody goes to mode, it needs to be in degree measure to start with. So whatever you want your answer in, that's the mode that your calculator has to be in. So when we're changing into degrees, we want to make sure we're in degree mode on the calculator. Okay, so here's what we're going to tell the calculator to do then. We're going to do our negative 3.5. That's the angle measurement. Oops, let me move this so you can see that. So negative 3.5. But here's the deal. If you just press enter right now, you haven't told the calculator that this is in fact a radian measure. So it would just say negative 3.5 right back at you. Like, what do you want me to do? What you have to do is tell the calculator, hey, this is radians. I want you to convert it to degrees. So you need to go to your angle menu. And under your angle menu, that number 3, we never used it before, but now this is when we need it. That's R for radians. So I want to change negative 3.5 radians into degrees. Make sure you say it's a radian measure then. Then press enter, and we're good to go. We have that angle measurement we came up with. Now going the other direction, I'll do that negative 1200 from up top. For that one, you have to change your mode then into radians, because what you want to do is you want to change 1200 degrees negative into radian measure. So we need to go the other direction. So whatever you want your answer in, that's what mode your calculator has to be in. All right, so let's try that. So we're going to type in negative 1200. Remember, if it's negative in one, it's negative in the other. But again, if you press enter right now, all it's going to say is negative 1200 right back because you haven't told the calculator yet, oh, hey, psst, this is degrees. I want you to change it over. So go back to your angle menu and say 1200 degrees and then press enter. And then we should be good to go. Now, the limitation of this is you can't ever get an exact answer when you do this. So you're not going to be able to get it in terms of pi. The only thing you'd be able to do is get it as a decimal answer, which might be good enough in a lot of situations that we're going to be dealing with. But you would have to do that manual conversion if you wanted something in terms of pi. I'm not sure this is really a shortcut, if this is any faster, but it's definitely a way to convert on your calculator without you having to do the multiply by 180 over pi or pi over 180. Okay, so why are we doing all of this? Well, I need you to be able to function well in both units of measure because I need you to be able to do things like this. So you're going to be finding values for special value angles, but they're written in radians as well. So I need you to be able to handle what a radian measure would mean. So when you see sine of pi over 6, what you should be able to think in your head when you do that is this is exactly the same as sine of, okay, now pi over 6, what would that be in degrees? Well, remember pi, whenever you think pi, think 180. So 180 divided by 6, 30 degrees. So it's sine of 30. It's the same question. It's the same location. You guys already know how to do sine of 30, right? That's the short leg. So it would be 1/2. So sine of pi over 6, exactly the same answer. So when we translate this, pi over 6 is the same triangle as what 30 degrees is. It gives you the same reference angle. Okay, let's try another one. So pi over 4, when we look at that, 5 pi over 4, let's kind of ignore the 5 for a second. We'll kind of think about just the pi over 4 piece. So just look at this. What is pi over 4 in degrees? So again, for pi, think 180. 180 divided by 4. Our reference angle, pi over 4, is equal to 45 degrees. So when I'm thinking this, I'm thinking, okay, what's cosine of 45? That's my reference angle, so that's what my ratio is going to be. So square root of 2 over 2. Now, the only thing you have to think about is where? Where is 5 pi over 4 then? Well, there's two ways to do it. You can just think of it in degrees. So if pi over 4 is 45, then I can do 5 times 45, and that puts me at 225. So this is really the same question as what is the cosine of 225? So where's 225? What quadrant is that in? Well, that's quadrant 3. So we know in quadrant 3 cosine is negative. So you can think that entire angle measurement if you want in degrees and figure out your quadrant from there. What I'm hoping you can start doing is figuring out where 5 pi over 4 is with counting in radians. So let's see if we can do that. If you're going to count in pi over 4s, halfway around the circle would be how many pi over 4? Well, it's quarters, so we'd need 4 of them, right? So we'd have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So halfway around, or the 4s would cancel, it would just be pi. So halfway around the circle is 4 of them. We want 5 of them, so we need to go 1 more pi over 4, or 1 more 45 degrees, which means we're in quadrant 3. So you can actually count your radian measures by using just the unit circle and count in those fractions, and it works exactly the same way because ultimately you've got to figure out if this thing is going to be positive or negative, and you need to know the quadrant to be able to do that. Okay, let's try another one. So tangent of 2 pi over 3. So again, we're kind of trying to translate this, figure out a reference angle. So what is pi over 3? It's our reference angle in degrees. So 180 divided by 3 would be 60. So in my mind, I just need to be thinking, okay, what's tangent of 60? Bigger angle, bigger ratio. For sure, that's going to be square root of 3 then. You just have to figure out what quadrant you're in. So if you want to function completely in degrees, I would just take 2 times 60. So that would be 120 degrees. So 120 puts you in what quadrant? That'd be quadrant 2. So tangent in quadrant 2, it would be negative. Works great. But again, if you want to count in pi over 3s, so think of it this way. We're going to count in pi over 3s, which is 60-degree intervals. So we'd have 1 pi over 3, 2 pi over 3. That would put me in quadrant 2, because remember, all the way to 3 pi over 3 would be halfway around the circle. So I need 1 less. So I'd be looking at that angle right there in quadrant 2. So 2 pi over 3 is a little bit less, 1 60-degree interval, or 1 pi over 3 less than 3 pi over 3. So I'm in quadrant 2. So however it's easier for you to think about it. Okay, let's talk about this last one, number 4. This one kind of bothers people because there's a little bit more to it. First of all, it's negative, so that kind of freaks people out. And it's a big number, right? 11, but we still have a reference angle we can look at. So the reference angle is pi over 3, and that means 60 degrees. So right away I know, okay, cosine of 60, that's a half. So I know my answer has to be a half. Now what you have to figure out then is just what the sign is. Is it positive or is it negative? So let's talk about our two options. So you can just go ahead and figure this out in degrees. So you know that 60 degrees is pi over 3. We can times by negative 11. We get negative 660. So if you want to focus on degrees and just do it in degrees, fabulous, negative 660. Now the problem is I'm not exactly sure where negative 660 is even. So the number you get may not be user friendly just yet. How do I make negative 660 into something that's more fun to work with or more recognizable? Well, find a coterminal. So I need you to find something that's coterminal with negative 660. So add 360 a couple of times, and where do you end up? Well, it's the same as 60 degrees. Does that help us out? Absolutely. Where is 60 degrees? That's in quadrant 1. So if this is a quadrant 1 angle, then I know cosine is going to be positive 1/2 then. So this is coterminal with a quadrant 1 angle. Sweet. So I can do it in degrees. That's totally fine. That's one option. The other way is just to get used to counting in radians again. So let's see if we can do that, because ultimately just counting in radians is probably faster. So we are going to measure in pi over 3. So we're going to try to measure in pi over 3. So this is a negative angle. So we're going to start here and we're going to go this direction. Let's start with this. So if I go halfway around the circle, that would be negative 3 pi over 3, right? Because the 3's would divide out. That would leave you with just negative 1 pi. That's halfway around the circle. So you need 3 pi over 3's to get halfway around. How many would you need to get all the way around? Well, that would be negative 6 pi over 3 then. Think about that for a second. 6/3, that reduces down to 2 pi all the way around the circle. So if you need 3 to get halfway around, you need 6 to get all the way around. All right, well, we want to go 11. So another 3 will get me another halfway around. That would take me to negative 9 pi over 3. Now, how many more do you need to go to get to negative 11? Well, 2 more. So 1 pi over 3 more would put you here. 2 pi over 3 more would put you there, and we're going to be in quadrant 1, that 60-degree reference angle. That would be negative 11. Now, if that's hard to figure out, just if you went one more, that would be negative 12 pi over 3, which would be too far, right? 4 pi twice around the circle. We only wanted 11, so it's got to be 1 less than that. So you still end up in quadrant 1 in the exact same location. So if you want to count in pi over 3's, it's just thirds. So you need 3 to get halfway around, so it'd be 6 to get all the way around. So whatever way makes more sense to you. Some people go back and forth depending on the angle too. Sometimes it's easier to work in degrees. Sometimes it seems like it's easier in radians. Whatever makes more sense to you. But what I need you to be able to do is confidently switch back and forth so we're able to talk about the angles we need to. So for our kind of day 2 notes, I know this is day 1 from actually in the book assignment, we're going to just work on that, changing back and forth from degrees to radians and then starting our sine, cosine, tangents of radian measures.